Hi guys, this formula we had derived via laws of vibrating string. Now this formula we are going to prove using sonometer. Sonometer consists of a hollow rectangular wooden box called a sound box, over which are placed two movable bridges. There's a string passing through these bridges round the pulley down there, attached to slotted weights with the help of a hook. Now this slotted weight, keeps the string stretched owing to tension of slotted weights. Alright. Okay, there's something called as a rider. Now rider is something like this, which is placed on the string like this, Alright. So piece of paper folded and placed on string that ways. Alright. This obviously is tongue. Now basically what is done is the prongs of tongue are head on bun, causing vibration into prongs. Then this is placed on the sound box, or just touched on the sound box. As soon as it is touched on the sound box, the air inside the sound box starts vibrating, as a result of which it's caught up by the string. The string also starts vibrating. Now basically sound box is meant for amplification of vibration produced by prongs of tongue. Okay, so this vibration is vibration which is amplified by sound box, by air in the sound box. So this starts vibrating. Fine. The rider does not fall. So now I again repeat the same thing. The prongs are vibrated and kept on sound box, but the rider does not fall. So what do? I adjust these movable bridges. I bring it closer or away. Whatever I do, I've got to do it in such a way, or bring those movable bridges at such a point or at such a distance where the rider falls. What does that mean? That means that the string is in resonance with the prongs of tongue. Resonance in the sense the vibration of this is equivalent to vibration of tongue. Alright. So we just, with the help of a scale, we measure the distance between the two movable bridges at which the rider fell. Alright, then we change the tongue, repeat the experiment, and then we know the frequency of tongue. We find out the distance between the movable bridges at which rider fell, and we call it as L, carrying on number of such readings, different N, respective L for that. We get N1, L1. N1 into L1 is equal to N2 into L2 is equal to N3 into L3. So what we find is that it's constant. If the frequency is more, length would be less. If frequency is less, length would be more, but the product would be constant. Now this itself means that frequency is inversely proportional to length. So N inversely proportional to length proved. Okay, so the next part is getting into N is directly proportional to root of tension. Now keep one thing in mind. When we did this, at that time we had kept M, small m, that is mass per unit length of the wire, constant, and even the tension was kept constant. Now we are carrying on the reaction for tension, frequency and tension. So obviously length of wire would be fixed and mass per unit length also would be constant. So the length, this length, now we are not going to touch these movable bridges now for this part of experiment. Alright, so length is fixed, and at the same time the wire also is the same wire which we are going to use. So mass per unit length is also the same. Okay, keeping this in mind, what we do is Now same thing what we do is we keep on changing the tension. So in this experiment we keep on changing the tension. By changing the tension, keeping length of the wire constant, now what we would do is prong, strike it, touch it, change the tension and find out the tension at which the rider falls. Strike it, touch it and then again change the tension or the slotted weight and see at what tension does it drop. So this way we can find out tension, and the frequency of fork is already known. So what we find is by changing tension T, keeping length of wire constant and made to vibrate in unison with tuning fork, made to vibrate in unison with tuning fork means at that point where this would drop out, the rider would drop out, and made to vibrate in unison with tuning fork of different frequencies, of different known frequencies. What we found is, we found that this ratio N1 over root T1. Now this root, as I mentioned earlier, that this root was found out experimentally. Alright, so what we found is N1 upon root T1 was equal to N2 upon root T2 equal to upon N3 upon root T3 is equal to constant. So what does that mean? That means N is directly proportional to root of tension. Alright, so N is proportional to root of tension, also done. So finally we have got to prove is N is inversely proportional to root of M, that is mass per unit length, with constant T and N. In this case, tension and frequency is kept constant. So two wires are chosen of different mass per unit length. Means now just to differentiate, how would you differentiate? Now see, one wire, suppose you have chosen a wire 1 meter length. Alright, now that 1 meter length wire may be thick or may be thin. So if it is thick and thin, if one is thick, other is thin, that itself means they would weigh also different. And if these wires weigh different, that itself means their mass per unit length is different. Alright, so you can just visualize, say 1 meter wire with smaller radius and 1 meter wire with a thicker radius, just to make you understand how can mass per unit length be different. Okay, so two wires chosen of different mass per unit length, that is M1, M2, vibrating length or the resonant lengths L1 and L2 found out. How? By same resonance dropping off. So what we would do is, here in this case, so experimentally we would have one wire fixed with mass per unit length, say M1, and tuning fork would be the same, whatever frequency, strike and then put it here on the sound box. This starts vibrating. I will find out the length at which the rider drops. So for M1 found out L1. Similarly, then I'll change the wire of different mass per unit length, that is M2, and then again strike the same tuning fork and then place it on sound box. Vibration, find out the length by adjusting these movable bridges at length at which the rider drops. So thus we got L2. So having known L1, L2, M1, M2, it was found that L1 root of M1 is equal to L2 root of M2 is constant. So frequency is inversely proportional to length, and frequency is also inversely proportional to root of mass per unit length. Proved. Alright, this is how we prove using sonometer the formula N is equal to 1 upon 2L root of T over M. Alright, hope you understood. Study well.